Welcome to the ITFreeTraining video on IPv6 Subnetting. A subnet is a logical division of a network. In IP4, subnetting decisions often had to be made due to a limit on address space. With IP6, the address space is far from limited. So let's have a look at how this affects subnetting in IP6. The main reason for subnetting in IP4 was to effectively utilize the small address space as best as possible. IP6 has a significantly larger address space, and thus 16 bits can be dedicated just for subnetting. This means that subnet masks are no longer required. With IP4, a subnet mask was required to divide the address into network and host parts. Well, I must say, these bullet points are kind of boring, so let's look at an example instead. Let's consider that an ISP has just given you an IP6 address ready for subnetting. Notice the /48. 48 bits have been allocated by the ISP. This leaves 80 bits. If the address is broken down, the first 48 bits have been allocated, the next 16 bits are the subnet ID, and the last 64 bits is the interface ID. The interface ID is configured by the node or via a service like DHCP, so for the purposes of subnetting, I don't need to worry about it. So, how would the administrator go about creating some subnets? The simplest first subnet that can be created is to set the 16-bit subnet ID to 0. For the next subnet, simply take this value to 1. For the next subnet, make the value 2, and the next subnet, make the value 3. This is a very simple example. However, for small networks, the administrator does not need to make it any more complicated than this. If you are familiar with IP4 subnetting, you will notice that the subnet mask is not required, making the process a lot simpler. So I think you can handle it. Let's look at a more complex example, but not too complex. So far, we have learned that IP6 has 16 bits dedicated to subnetting. This allows the administrator to divide their network up into logical subnet networks. To start with, I will allocate 4 bits of the subnet to a country. 4 bits gives 16 countries, so allocating this many bits allows the network to support 16 different countries. Notice that when 4 bits have been chosen, the following happens. The first value of the subnet in the IP address ranges from 0 to F in hexadecimal. Next, I will allocate a further 4 bits to different states. This means each of the 16 countries can support 16 states. Looking at the address, the second value will also range from 0 to F. Next, I will allocate 4 bits to different offices. You probably guessed by now, the third value will range from 0 to F, giving 16 values. Lastly, I will allocate the last 4 bits to different departments. Like before, the last value will range from 0 to F. So this network will support 16 countries, which can have 16 states, which can have 16 offices, and each office can have 16 departments. The point to understand here is that if you align the subnets with 4-bit boundaries, the subnetting is very easy. I could have also used 8 bits. For example, 8 bits gives 256 values, so this could give 256 countries. A further 8 bits could be used to give 256 networks for those 256 countries. Something to think about to make your network simpler to work with. But unfortunately, your organization may not work off 4-bit boundaries, so let's look at a harder example. In this example, once again, the ISP has given us the same IP address. This time, the 16-bit subnet ID will be divided up into 5 bits for the country, 6 bits for the state, 3 bits for the offices, and 2 bits for networks in those offices. Unfortunately, the subnet ID has not been divided up into 4-bit boundaries, so now some math is involved to work out the network. Rather than look at the math in this video, I will instead use an online subnetting tool. I will leave the math to an upcoming video. To do this, I will open Internet Explorer and go to the site Gestio IP. This site contains an IP6 subnet calculator. If you have trouble finding this site, I've left a link to it in the references part of the video, and also for the next website I will use later in this video. From the website, I will select the link in the middle of the page, Subnet Calculator Online. Once the page is loaded, I will select the option for IPv6 Subnetting and then enter in the IP address given to me by the ISP. Next, I will set the prefix length to 48. Now that the IP address has a prefix length, the next step is to press Calculate. Once the page is loaded, if I scroll down, this will show details about the current IP address. So far, none of the 16 bits have been allocated to any subnets. At the bottom, I can select how many networks the subnet will have. I require 5 bits. 5 to the power of 2 is 32 subnets, which is not shown. To show this option, I will need to select the More option. I will then select the option 32 networks from the list. Once selected, notice at the top, a network has been created with a prefix length of 53. So essentially, 5 bits have been used to create these subnets. The next step is to allocate 6 bits for the subnet to be used with the state. To do this, I will select the option 64 networks, which is 2 to the power of 6. The next network is for the offices, which requires 3 bits, so 2 to the power of 3 is 8. So I will select the option 8 networks. Lastly, there are 2 bits required for networks at each office, so I select the option for 4 networks. All the 16 bits from the subnet ID have now been allocated, so next I will select the option for Create Plan. This IPv6 calculator allows each level of networking to be named. For the first level, I will enter in Country and press Send. For the next level, I will enter in State and press Send. The next level, I will enter in Office and press Send. Lastly, the calculator will ask for the number of networks for the last level. For this, I will enter in 4, which is the maximum number, and press Send. Once the calculator has run, a breakdown of the subnets will be shown. At the top, notice level 1 for country. Essentially, it is saying bits 48 to 53 will determine which country the address is. Below this is the level 2 address for state. Since all the subnet ID values are 0, the address is the same as the previous one. However, the prefix length is changed to 59, essentially meaning that bits 53 to 59 are dedicated to the state the address is for. Following this is the office part of the IP address, which is using bits 59 to 62 in the IP address. The last part is a bit more interesting because the 2 bits used have been expanded to 4 subnets. The interesting thing to look at is that you can see part of the address going up from 0 to 3. This subnet calculator is good for getting a quick breakdown of the network, but does not give much detail about the different subnets. To get some more detail, I will open the web page Subnet Online. Once the page is opened, I will select the menu Subnet Calculators, and then select the option IPv6 Subnet Calculator. Like before, I will enter in the IP address given to me by the ISP, and then set the prefix length to 48. This subnet calculator is a little different than the other calculator in that you need to enter in the number of subnets you want. From this information, the calculator will work out the number of bits required. In this case, I will enter in the value of 17 and press Add Level. 32 will be the maximum number of allocatable subnets. However, 17 is the lowest number I can enter that will use 5 bits. I entered in this value because the calculator will expand all the subnets entered in. If the total number of subnets is too high, the process will fail. Next, I will enter in the value 33 and press Add Level. This is the lowest number that will use 6 bits. You can see that if you are not sure how many bits you need, you can enter in some values and it will tell you how many bits are required. For the next level, I will enter in 5, which will use another 3 bits of the subnet ID. And for the last level, I will enter in 4, which will use 2 bits. Now that all of the 16 bits of the subnet ID have been allocated, I will press the button Calculate Subnets. The process should not take too long to complete. It all depends on how many subnets were entered. Once complete, at the top, notice that original IP address with the network prefix of 48. If I expand this, this will give the first level of subnets. You can see the first subnet. The subnet part of the IP address is all zeros. Notice that the next subnet ID starts with 800. Following this, the next subnet starts with 1000. Notice that each subnet increases by 800 each time. Remember that the address is in hexadecimal. If you are not familiar with hexadecimal, you should at least see a pattern repeating itself. In this example, these addresses will be allocated to different countries. I now expand the second level of addresses. These would be the addresses that would be used to allocate to each state in that country. Notice that the addresses are going up by 20 each time. Since it is hexadecimal, notice that the sequence will go A0, C0, E0 before going back to 0. The amount that this goes up this time is very small compared with before. If I now expand the next level, this will give the subnets for the office. If I expand the last network, this will give the subnets for use for networks in each office. Notice in the last level, the subnets go up by 1 each time. This is to be expected since all the subnet bits have been used. If I expand another subnet, notice that sequence continues. Each subnet increases by 1. If I expand the next subnet, notice the sequence continues again and starts using the hexadecimal alphabet characters, which continues on into the next subnet and the next subnet. As you can see, working out the subnets is a matter of working out the value that needs to be added to the previous subnet. The online calculator takes all the hard work out of the process. In the next video, I will look at the math required to manually work out subnets in IP6. I hope to see you in that video. Until then, I would like to thank you for watching this video.